All right, today we're going to talk about the Pythagorean theorem and its converse. And you probably remember the Pythagorean theorem from Math 1. And so we know that that has to be of a triangle. And more specifically, it deals with right triangles. And we're going to talk about how to use the Pythagorean theorem to find missing sides, either a leg or a hypotenuse. And that's pretty much what you did with that last year. Then we're going to talk about its converse. So if you have three sides of a triangle, how can we determine if it's a right triangle or not? And that would be using the converse of the Pythagorean theorem. So just as a quick review, the Pythagorean theorem, remember, is leg squared plus leg squared equals the hypotenuse squared. And we use the letters A, B, and C. A and B are legs, and C is the hypotenuse. And if you recall, your hypotenuse is always the longest side of a right triangle, and it is located across from the right angle. So we generally use C to represent the hypotenuse, and then the two legs are A and B. And they're interchangeable. It doesn't matter who you call A and who you call B. So if you want to, you can pause the video and see if you can remember, using the Pythagorean theorem, how to find a missing side of a right triangle. So you're going to be given two sides, and you're going to be missing a side, whether it's a leg or a hypotenuse. All you do is simply plug your numbers into the formula or the equation, and you solve for either A, B, or C. So you can pause the video and see if you can do 1 and 2, and then unpause the video and see if you get them correct. So number 1, I have two legs that I'm given, 17 and 7, and we're missing the hypotenuse. So the hypotenuse is what we've got to solve for. So I'm going to say A squared plus B squared equals C squared. So leg squared plus leg squared equals hypotenuse squared. So in my handy-dandy calculator, I'm going to put in 17 squared plus 7 squared, and I get 338. Now I'm not done because I don't have x by itself. To undo a square, you take the square root because they're opposite operations. So the square root of 338 is 18.4. And my instructions tell me I can round to the nearest tenth if needed, so I don't have to worry about simplifying that radical. Number 2, I'm looking for a leg this time, but you're going to still use that same formula where you say leg squared plus the other leg squared equals the hypotenuse squared. So to solve this equation, I need to get the x squared by itself, so we're going to simply subtract the 22 squared from the other side. So I get x squared equals, in my handy-dandy calculator, I put 25 squared minus 22 squared, and I get 141. To undo a squared, you take the square root. So the square root of 141 to the nearest tenth is 11.9. So that is some example problems. Should, strike some memory there from when you guys did the Pythagorean theorem last year. Then we have what's called a Pythagorean triple. A Pythagorean triple is a set of 3 non-zero whole numbers. A set of 3 non-zero whole numbers. Such that A squared plus B squared equals C squared. In other words, if you're using the Pythagorean theorem and you get all three sides are whole numbers, then it's called a Pythagorean triple. And the popular one that we see most often is the 3, 4, 5 triangle. If you have sides of 3, 4, and a 5, you have a right triangle, and that satisfies the Pythagorean theorem, and they're all whole numbers. So that's an example of a Pythagorean triple. All right, so the converse of the Pythagorean theorem, instead of saying if you have a right triangle, then A squared plus B squared equals C squared, this is the converse of it, which would say if A squared plus B squared equals C squared was true, then the triangle is right. So if you have sides of a triangle and it satisfies the Pythagorean theorem, then you can conclude that that triangle is a right triangle. Because sometimes you're going to be asked to determine what type of triangle it is. And then following that, we have the Pythagorean inequality theorems that says if your A squared plus B squared is greater than your C squared, then the triangle is acute. And of course, we can reverse that inequality and say a squared plus b squared is less than c squared. Then the triangle is obtuse. So just make sure you study the inequality so you know if it's acute or obtuse. And I usually look at it from the c. If I look at the c squared and that c squared is smaller than the leg squared, then it's acute, because I always associate acute with smaller than, so that would make better sense if you do your c squared first. Again, if you do your c squared first and you notice that that number is greater than the leg squared, the sum of the legs squared, then you can say that triangle is obtuse. All right, so we're going to do some practice, and they're going to ask us first if the measurements can even make a triangle. So we have to kind of think about what would make a triangle. I thought all three sides would make a triangle, and that is incorrect. Because if you have, for example, and I'm just going to jot this down over here, a little note. If I have sides of 1 inch, 1 inch, and 2 inch. If I try to cut little pieces of paper out and I get 1 inches and another 1 inch and a 2 inch, there's no way I can connect those three sides together to make a triangle. Whereas if I had a piece of paper that was 2 inches, 5 inches, let's see here, and we'll just say 8 inches. Again, if I take a look and I cut little pieces of paper out that are 2, 5, and 8, there's no way I can make a triangle. So the 2, 5, and 8 would not be a triangle either. So what would suffice a triangle? Well, think about the 3, 4, 5 triangle. Okay, this one is a triangle. Those two are not. So let's see if we can find a pattern here. If you add the two shortest sides, 1 plus 1, that equals 2. It needs to be greater than that third side in order to make a triangle. Take a look at 2 and 5. If I add 2 and 5, I get 7. Again, that is not bigger than that third side, so it does not make a triangle. Now, if you take a look at the 3, 4, 5 triangle, if I add 3 and 4 together, I get 7. 7 is bigger than 5. So the rule here to determine if the three sides they're providing you could even make a triangle is the sum of the two shortest sides must be greater than the third side, or the longest. Let me say the longest side. So always check to see if you have a triangle before you determine if that triangle is right, acute, or obtuse. And the way we do that is we simply take the two smallest sides, add them together. And it's got to be greater than the longest side, or the third side, which is generally your longer side. All right, so let's take a look at number 1. We want to first go through and determine, can these even be sides of a triangle? So number 1, what I'm going to do is I need to add the two shortest sides and see if that's going to be bigger than the third side. So 11 plus 60 added together is 71. That is greater than the third side. So yes, this is a triangle. And now that I know it's a triangle, I can classify it as acute, right, or obtuse by using the Pythagorean theorem. So determine if the sides can be a triangle. Yes, it's a triangle. Now we have to determine what type of triangle it is, so we're going to use the Pythagorean theorem. So I'm going to take the two shorter sides, square them, add them together, and see what the relationship is with the third side. Are they equal? Is it greater than, or is it less than? So we need to determine the relationship between that leg squareds and the hypotenuse. So I'm just going to put an equal sign for now with a question mark. We want to know, are they equal, less than, or greater than? So in my calculator, I'm going to put 11 squared plus 60 squared, and I get 3,721. Then on my calculator, I'm going to put 61 squared, and I get 3,721. And so those values are equal. Because they're equal to each other, we have a right triangle. So number 1 is a right triangle. So after you have determined it can be a triangle, you have to tell us what kind of triangle it is. All right, so number 2, if the radicals kind of scare you a little bit, you can put them in the calculator and see what their decimals are when you're trying to determine if they are triangles. So I've got my 2 radical 3 plus my 4 radical 2, and I got 9.12. So these two give me 9.12. So the question is that greater than the 3 radical 5? 3 radical 5 is 6.7. Because that's greater than, this is a triangle. So now I have to determine what type of triangle it is. So I would use the Pythagorean theorem. And I'm going to put parentheses around this, and it might make sense in just a second, because if you don't put parentheses and you're using a calculator, you're going to get the wrong answer. So I'm going to put my 2 shorter sides together. I don't know if that's equal or not to the 3rd side. If it is, then it's a right triangle. If it's not, then I have to determine is it acute or obtuse or right. Acute or obtuse. All right, so 2 radical 3 squared. And I can do this really easily without a calculator. All I do is square the 2. Let me show you guys a little trick here. I can square this 2, and you get 4. And then you've got radical 3 squared. Oops. Let's try and do a different color here. Radical 3 squared. Radical 3 squared, remember, is radical 3 times radical 3, which is regular 3. So that gives me a 12. 4 times 3 is 12. Okay, let's do that again. 4 squared is 16. Radical 2 squared is regular 2. 16 times 2 is 32. Let's do that one more time. 3 squared is 9. Let me put that up because I don't want it there. And then radical 5 squared is regular 5. 9 times 5 is 45. So again, you could have used the calculator, or you can just use simple math. All right, so 12 plus 32 is 44. 44 does not equal 45. As a matter of fact, my 45 is larger than that 44. So remember, you look back up at your Pythagorean inequality theorems there, and you have to determine, is it acute or is it obtuse? And so because my C is larger than my A and my B, this is going to be an obtuse triangle. So number 2 is an obtuse triangle. All right, let's take a look at number 3. First, we have to determine, is this a triangle? How do we do that? We add the 2 smaller sides together. So 6.2 plus 13.8 is 20. That has to be greater than the 3rd side, and it's not. So this cannot be sides of a triangle. So this is not a triangle. So we are not going to classify this as acute, right, or obtuse because it's not even a triangle. Okay? So now we are moving on to number 4. Number 4, I don't have any graph paper. Do you have any graph paper? It's okay, we don't need graph paper. In order to classify this triangle, and I will tell you, if you have ordered pairs on a coordinate plane, you can connect the 3 dots and make a triangle. So I don't have to determine, is this a triangle? I know it's a triangle. Any 3 points on a coordinate plane will make a triangle. All right, so I need to figure out their side lengths in order to determine, is it acute, right, or obtuse? So the way that we find the side lengths is we use the distance formula. Do you guys remember the distance formula? I think we've already used it this semester. It's x minus x squared plus y minus y squared. And we're going to do this for the 3 sides of the triangle. We have side xy, we have side yz, and we have side xz. So I need to figure out the distance of each side, because that'll give me the length. If I find the distance between those points, it'll give me the length of the sides. All right, so xy would be -3 minus -1, makes that a +1. Don't forget your squared. Plus, my y values are -2 minus 0. Don't forget your squared. So do a little mental math. That gives me -2 squared in the first set of parentheses, so that would be 4. And then the other parentheses is -2 take away 0 is also -2 squared, which is 4. So you end up with 4 plus 4, which is 8. And I'm not going to put that as a decimal. I'm going to leave it as a radical, and you'll see why in just a minute. We'll do the same thing for yz. So I've got my x's are -1 and 0. Don't forget your squared. 0 take away a -1 is a +1. So mental math tells me that is 1 squared, which is 1, plus another 1 squared, which is 1. 1 plus 1 is 2. So that has a length of radical 2. And then xz is going to be -3 and 0. Don't forget your squared. -2 take away -1 becomes a +1. Don't forget your squared. So mental math, that gives me -3 squared is 9. And then I have a -1 squared is 1. 9 plus 1 is 10. You can always put that in your calculator to verify that that is true. All right, so I have 3 sides. Now I'm ready to use the Pythagorean theorem. And so I'm going to say radical 8 squared plus radical 2 squared. Does that equal radical 10 squared? Well, we know if we take radical 8 and we square it, I get a regular 8. Let me slide this over this way. Radical 2 squared is regular 2. Radical 10 squared is regular 10. And we know 8 plus 2 is 10. So that is a true statement. So yes, this is a right triangle. And you'll have some on a worksheet like number 4 where you have to determine the side lengths by using the distance formula. All right, and so that is the Pythagorean theorem. Should be a review of Math 1, and of course the only difference there is the Pythagorean inequality theorem, where you have to determine is it a right, acute, or obtuse triangle based on if it's equal to, greater than, or less than that c squared. All right, so use these notes. Hopefully they were helpful, and then use that, or to do the practice sheet, make sure you take a picture of the practice sheet, upload it, and send it in Google Classroom, and I will see you guys later. Let me know if you guys have any questions. Bye.